Now the problem asks you to calculate the acceleration as well, and that's very straightforward. One thing I haven't talked about in any of this, but y'all are doing it, and I think you all know it, and I think you all understand it, and please let me know if any of you have any problem with this. The acceleration is the net force divided by the mass. And what's the mass? Well, the weight is the mass times the acceleration of gravity, which means that the mass is the weight divided by the acceleration of gravity, which is 0.5 newtons over 10 meters per second squared. And incidentally, we use 10 meters per second squared whenever we're not overly concerned with precision. Note that 10 meters per second squared gives you very much a 2% error, very close to 2% error in the calculation of the gravitational, well, in the value of the acceleration of gravity. And dividing by something that's 2% too big gives us an answer that's 2% too small. And so this would actually be like 0.051 kilograms if we use the 9.8 meters per second squared. And that's a handy kind of calculation to be able to do in your head. 2% is easy, 10 is an easy number. Okay, so we divide that, we find that the mass of that cart must have been 0.05 kilograms. So that if the cart is moving up the incline, the acceleration is net force over mass. Net force being negative, over here, this is up the incline, negative 0.035 newtons times I, divided by the 0.05 kilograms, gives us 7 meters per second squared times I, meaning 7 meters per second squared in the I direction, the I direction being this way. If down the incline, well, I'm not going to go through the details. We got the 0.015 newtons times I here, and I didn't write the I. Okay, well, that's not a very good place for the I. It looks like part of the equal sign, but still it's there. And we get 3 meters per second squared times I.